Hello, my name is Angela Martinez. I'm going to speak about muscular dystrophy. The title of my presentation is Muscular Dystrophy, a devastating disease with hope of cure. Muscular dystrophy englobe all these conditions that I wrote here: Duchenne, Becker, congenital, myotonic, emery-Dayforth, scapulohumeral, oculopharyngeal, and limb-girdle muscular dystrophy. It's a group of genetic conditions that produce weakness on the muscles. Most common of them are Duchenne and muscular dystrophy and Becker muscular dystrophy that are the ones that I'm going to explain on my presentation. There is not definite treatment for this disease, but now a hope is born for patients because there is some studies still in the testing phase, but show a really encouraging results. The cause of this condition, as I already told, is an X-linked recessive disorder and due to frameshift or nonsense mutation. And this is important to understand the treatment. Okay, it's X-linked recessive disorder because it's transmitted from the mother to the male child through the X chromosome. So almost 100% of the patients with this condition are males. It's a frameshift mutation because during the transcription process of our DNA, we have some structures that codify for amino acids, and the name are codons, and they are formed by 3 nucleotides. Sometimes in this disease, one nucleotide is added or is removed, so you cannot divide a codon by 3, and this causes a misreading on the DNA strain. Other kind of mutation, it could be a nonsense mutation. It's happened when there is a stop codon. When you are doing the transcription of the genetical material of the DNA, and you found this stop codon, the transcription stopped. So you're gonna get a shorted protein, non-functional, and the name of this is a truncated protein. And this gonna help us to understand what is the difference between Duchenne and Becker muscular dystrophy, because Becker is due to non-frameshift deletion. So the dystrophin gene is partially functional instead of truncated. It's important to understand what happened with the muscle fiber, and I'm going to explain what is dystrophin. It's a small protein that helps anchoring the intracellular cytoskeleton to the extracellular matrix, and it's going to do that through the dystroglycan, that is a transmembrane protein. It's gonna form a kind of a complex. The name is dystrophin complex, and this complex helps reducing the mechanical stress that is going from the extracellular matrix to the cytoskeleton. When you don't have this complex, all this mechanical stress go directly and can cause something called myonecrosis and progressive myofibers damage. The symptoms is weakness that begins in the pelvic girdle, pseudohypertrophy of calf muscles, waddling gait, respiratory insufficiency, and finally dilated cardiomyopathy that is the main cause of death in this kind of patients. The diagnosis is with genetic testing, the gold standard CPR, multiplex ligation dependent prof amplification is available too, and in some countries that are underdeveloped or they don't have enough technology, they are still relying in histopathological diagnosis. What is the treatment? The treatment is aimed to slowing muscle weakness and prolonging lifespan. Corticosteroids are medication that can slow progression, and sometimes they are complemented with physiotherapy. As we know, the heart is a muscle, So we have to use some medication that stop cardiac remodeling, as the angiotensin converting enzyme inhibitors and angiotensin II receptors blockers, for all the patients with reduced systolic cardiac function. And sometimes they need pacemaker, implantable cardioverter defibrillators that could prevent complications from life-threatening conditions, defects, and arrhythmias. Finally, the novel genetic therapy restored dystrophin protein production, and there is 4 kind of therapies now in a study, but that I'm going to start with utrophin upregulation. Utrophin is a protein very similar to dystrophin. It cannot do exactly the same function, but is very similar. The problem with it with utrophin, that is an embryonic protein, and when the baby born, stop producing it. So the new technology is helping to keep producing utrophin after birth. The stop codon read through therapy, to make it simple, it just allow this cell don't sense the stop codon, so it can continue with the production of the protein. When the problem of this therapy is that just work for nonsense mutations to change muscular dystrophy. Viral gene therapy uses some viruses like adenovirus that work as a vector that carry genetic information to produce more dystrophin. And finally, the antisense oligonucleotides, simply it's gonna help to reframe the transcription process, and the organism can produce kind of a partially functional dystrophin. It's not a perfect dystrophin, but have some function. Finally, I have to say that unpublished results from the first phase of one trial of viral gene therapy have exceeded expectations, with dystrophin concentration reaching up to 80% of normal levels. So this is very encouraging, and is a very good news for all the patients suffering from this condition. Thank you for hearing my presentation. Have a good night.